everybody, Mrs. Pesic here. We're going over the rest of the problems from the semester exam review sheet. We're graphing the inequality y is greater than negative 2x squared plus 2x plus 4. We know this is going to be opening down because the leading coefficient here is negative. And we know that we can graph this on our calculator, negative 2x squared plus 2x plus 4. So let's graph that, negative 2x squared plus 2x plus 4. All right, and so when we graph that, we see that it does indeed open down. We can get the vertex from this by going Menu, Analyze Graph, Maximum. Since it does open down, it will have a maximum value. I'm going to get to the left of that maximum to get the lower bound, and then slide over to get my upper bound and click. That grayed area is the search zone, and it tells me that the vertex is at 0.5, comma 4.5. So I can fill that in right here. 0.5, comma 4.5. I can find the y-intercept also either manually by plugging in 0 for the x's here and here, and that term would drop out and that term would drop out, leaving me just with 4. Or I can get that same information by looking at that same graph that I have on my calculator. And that's right here. And I can look at where it crosses, and I can also do Menu. No, I don't want to do Menu. I want to do Control T, and I can pull up a table and see that at 0 it is equal to 4. All right, but what about the shading? So if we want to talk about the shading, since this is an inequality, let's plot what we have. So we've got 1/2 and then 4.5, which is right about here, and then 0.4 would be right here. I know it opens down. By the way, it's a strictly greater than, so that means it's not greater than or equal to, which means I do want a dotted parabola, so it's going to look something like this. And since it's a greater than, that means I do want to shade above the parabola. So I want to shade all of this area above the parabola. And we can also get that same graph by doing this on our calculator. We can, I'm going to add a new graphs page, and if I go to a graphs page and I just actually do a backspace, and I wanted to do greater than, it changes it to y greater than. I wanted negative 2x squared plus 2x plus 4, and there's our same graph, and you can see it is shaded above. All right, let's take a look at number 27. We're solving the inequality by using algebra, so write your answer in interval notation. So if we're solving by using algebra, we're going to subtract 6 from both sides. We get x squared minus 5x plus 6. And let's just use equals 0 right now instead of greater than 0. So we're going to actually find the critical numbers. We're going to do that by factoring. So the product here is 1 times 6 is 6, and the sum is negative 5. So the two numbers that would work would be 6 and a negative 1. I think that would not work. How about negative 3 and a negative 2? That'll multiply together to give me positive 6, and they'll add up to negative 5. So I'm going to write x squared minus 3x minus 2x plus 6. I'm going to factor by grouping, so I have x times x minus 3 and a minus 2 times x minus 3. I think that'll work. And then we have x minus 3 in both places, so I'm done when I write x minus 3 times x minus 2. But remember, this was equal to 0, so I have to set this equal to 0, and I solve that by setting each factor equal to 0. So it looks like I'm getting x equals 3, and I'm getting x equals 2 as my critical numbers. And so what I'm going to do as my next step is I'm going to draw a number line, and I'm going to put those two numbers on my number line. There's 2, there's 3. I'm going to pick some test points because those two critical numbers are splitting my number line into 3 regions. This region that's over here, and I'm going to pick, let's say, 0 as a test point here, and I need a point that's in between 2 and 3, so let's do 2.5 as a test point, and I need something that's over in this region here, like let's say 4 as a test point. I want to plug those all in individually into the original inequality to see whether it's a true statement or false statement. If I try plugging in 0, I get 0 squared minus 5 times 0 plus 12. Is that greater than 6? So that's going to be 12 is greater than 6, and that's a yes. So I'm going to write a yes right here, because not only does 0 work, but everything in this region here is going to be a solution. Let's try the next one. I'm going to plug in 2.5. This one I might just use my calculator for this. I want 2.5 squared minus 5 times 2.5. I am going to a calculator page. So I want 2.5 squared, and then I want minus 5 times 2.5, and then I want plus 12. I'm getting 5.75. Is that greater than 6? 5.75 is greater than 6. That's what I got when I plugged in my test point of 2.5. That's a no, so I'm going to write a no right here. And let's try 4. So if I try 4, I could do that on the calculator or by hand. So 4 squared minus 5 times 4 plus 12, is that going to be greater than 6? Well, this is 16 minus 20 plus 12. I'm getting a negative 4 plus 12 is 8. And then 8 is greater than 6. That's a yes. So this region is a yes. So our solution is going to be anywhere that our region shows a yes. Well, that's going to be here, anywhere less than 2. So I'm going to write negative infinity to 2. And I don't want to include the 2 because this is a strictly greater than here. So I'm going to use a parentheses. Union with, let me erase my work here because I'm getting kind of messy here. And so I'm going to bring this down here, and union with this entire region over here, so that's union with from 3 to positive infinity. And so this would be our solution for this problem using algebra. Let's take a look at this one. A consultant advises the owners of a beauty salon that their profit P each month can be modeled by this quadratic equation, where X is the average cost that a customer is charged. Okay, so what range of costs will bring in a profit of at least $48,000? So let's do this whole thing on the calculator. We basically are wondering, when is negative 50x squared plus 3,500x minus 2,500? We want to know, when is that going to be at least 48,000? So greater than or equal to 48,000. So that's what we're going to enter in our calculator. So that is, we need to do this on a graphs page. Okay, so I'm going to do negative 50x squared plus 3,500x minus 2,500. So I'm graphing that. I don't see the whole graph, but that's okay. I'm not worried about that. I'm going to push tab, and I'm going to do the right side, which was 48,000. I'm not seeing that. Tab. Okay, let's try this. 48,000. Okay, so now I'm going to do Control T, and I'm going to pull up a table, and now I can compare the numbers in this column, which are my parabola values, to the numbers in this column, which is the 48,000 I'm trying to get. So it looks to me like we have to sell at least, really at least 21. But we need to charge our customers at least $21 to get that profit to be over 48,000. But if we charge too much, it starts dropping. You can see it going down right now, and it looks like we're going from 21 to, I went too far, 21 to 49. So we would say our answer for this problem is from $21 we can charge to $49. All right, let's take a look at some things from section 2.8. It says write a quadratic function in standard form that fits these points. And if we want a quadratic function in standard form, let me, I think I'm going to need more room here, so I'm going to copy this onto another page. All right, that didn't copy really cleanly, but that's okay. You've got the copy there. All right, so we're going to write all of these. We're going to plug them all into this equation, y equals ax squared plus bx plus c. So we're going to plug in negative 4 for x and 9 for y. So I get 9 equals a times negative 4 squared plus b times negative 4 plus c. That means I can simplify this to negative 4 times negative 4 is a positive 16, so I have 16a minus 4b plus 1c equals 9. I want to do this 2 more times with this order pair and this order pair. So let's go to 0, negative 7. So if I do that, I have negative 7 is equal to a times 0 squared plus b times 0 plus c. I plugged in 0 for my x's and I plugged in negative 7 for y. And so simplifying this, I get 0a plus 0b plus 1c equals negative 7. We're going to do this one more time with the 1 comma negative 1. So I get negative 1 equals a times 1 squared plus b times 1 plus c. And so that gives us 1a plus 1b plus 1c equals negative 1. So the equation, we want to write this system of equations here as a matrix equation. And the way we do that is we have to have a coefficient matrix times a variable matrix. And when we multiply those together, we will get our constant matrix. So the coefficients are these numbers that are being multiplied by the a, the b, and the c. So that would give us 16, negative 4, and 1 in our top row, 0, 0, 1 in our second row, 1, 1, 1 in our third row. Our variables are the a, the b, and the c. So we're going to fill those in here. And then the constants are just these numbers here. So that's going to be the 9, negative 7, negative 1. All right, in order to solve this matrix equation for this mystery matrix here, we can solve for ABC by taking the inverse of this matrix times this matrix. So let's rewrite our coefficient matrix, 16, negative 4, 1. Try this a little bit neater. 16, negative 4, 1, 0, 0, 1, 1, 1, 1. But we want the inverse of that matrix, and we indicate that with a little negative 1. Times this constant matrix of 9, negative 7, negative 1. All right, at this point, we're going to just let the calculator give us this answer. We need to type this in. So going to our calculator, I just want a calculator page. And I'm going to push this button right here. That's right to the right of the 9. I want this icon right here. It says, do you want a matrix 3 by 3? I do. I'm going to do 16, tab, negative 4, tab 1, and so on. So I'm typing all these in. And I'm going to do a right click to get out of the matrix. I'm going to raise this matrix to the negative 1 power, which means I'm really taking the inverse of that matrix. I need to do a right click to get out of that exponent. And I want to multiply this by another matrix. So I'm going to push that button again to get to the matrix. This time I want 3 by 1. And at this point I'm typing in the 9, the negative 7, and the negative 1. When I push enter, I get 2, 4, and negative 7. That means this is my A, this is my B, and this is my C. All right, so that means our answer for this problem, the quadratic function is going to be 2x squared plus 4x minus 7. We just had to fill it in where the A, the B, and the C were. All right, let's take a look at, got to go back and pick up number 30. Here we go. For number 30, it says find a quadratic model using your Inspire for the wattage of fluorescent bulbs F given the comparable incandescent bulb wattage I. Okay, so we're going to enter this data in our calculator on a list and spreadsheet page, and then we're going to do quadratic regression on this. So we're going to clear this ink out. We're going to add a list and spreadsheet page, and up here I'm going to call this incandescent. I'll just abbreviate InCan here, and then this one is fluorescent. All right, I'm abbreviating that, and I'm entering the data here. So I get 40, 60, 75, 90, 100. And here I have 11, 15, 20, 23, and 28. Remember to push enter after that last 28. And I want to now go to a calculator page. I'm going to do menu, statistics, stat calculations, and I want quadratic regression. And so I'm going to do a right click. My X list was incandescent. My Y list was fluorescent. Notice on my calculator it's storing it in F4. On yours it might be storing it in F1. Who knows what it's storing it in? I'll say OK. And here is my model. So I can write down y equals 0.00163 x squared plus 0.04813x plus 6.48. So that's a pretty good model for this. And then we are supposed to do a follow-up. It says use the model to estimate the wattage of a fluorescent bulb that produces the same amount of light as a 120 watt incandescent bulb. So at this point it might be good to add a graphs page, and mine was stored in F4, so I'm going to do an up click. There's my function, and I'm going to push enter, and I see a little bit of it, but I really am just interested in going to the table, so I can do Control T. Actually, I don't think I want to do that because that's I'm going to have to, if I do Control T, then I just lost my function. Tab, F4, enter, there's my function. If I do Control T, I could do this, but then I got to go all the way down until this number is 120. Okay, that's a lot of button pushing, so let's do this a different way. I'm going to get rid of that table, and this time I'm going to teach you something else. Menu, trace, graph trace. At this point I can type in anything I want for the X, and it'll give me the ordered pair. So I can just type in 120 like this, push enter, and it takes me right to the fluorescent. So this is the incandescent ordered pair right here, 120, and the fluorescent is right here. So I think our answer would be 35.7 watts. All right, let's take a look at number 31. Now we're in section 2.9. It says write the expression as a complex number in standard form and show your work for A and B. So for this one, if we're subtracting, I would rewrite this as an addition problem, but that means I have to change this sign and change this sign. So I want this to be a positive 5, a minus 6i. Now I can add like terms, so 4 plus 5 is 9, and add the imaginary parts. So I added the real parts, now I'm adding the imaginary parts, and I get minus 8i. So I get 9 minus 8i is the answer for this one. All right, let's try this one. This time we're multiplying, so we're going to do FOIL. So 2 times a negative 3 is a negative 6. Outer terms would be a 8i. Inner terms would be a negative 3i times a negative 3 is going to be a positive 9i. And then the last terms would be a negative 12i squared. All right, we can combine these and get 17i, so I get negative 6 plus 17i. But over here, this I squared is equal to negative 1. I squared is always equal to negative 1. So that means I really have minus 12 times a negative 1. So that's a negative 6 plus 17i plus 12. And then I can combine my 12 and my negative 6, and I end up getting 6 plus 17i is my answer for letter B. Now, what about C? I'm trying to do 5 minus 2i over negative 6 plus I. This one, we're just going to do the whole thing on the calculator. So if I go to a calculator page or scratch pad, and let me clear this ink off here, and so if I'm going to enter this ratio, I'm going to do Control and the divided by key to pull up a fraction template. I want 5 minus 2, and I have to use this pi button to get this special I, and then down click, and I want negative 6 plus, and again I need that pi button, and I'm going to get the special I. I just need to push enter, and I get my answer of negative 32 over 37 plus 7/37 times I. So that's your answer for part C. All right, let's go on to number 32. It says find the absolute value of the complex number, negative 6 plus 2i. Well, the formula for absolute value of a complex number, hang on, let's get this formula. Formula of absolute value of a plus bi is equal to the square root of a squared plus b squared. This is always a plus. If your b is negative, that's okay, because your negative number is going to end up being squared, but this is going to stay a plus always. So in this case, we want the square root of negative 6, quantity squared, plus we had a positive 2 that we're squaring. Remember, the I is not in this formula at all. We don't square the I. So this is just square root of 36 plus 4, which gives us square root of 40. And we can simplify that because this can be split up into square root of 4 times square root of 10, where 4 is a perfect square. And so square root of 4 is 2, and we can't do anything with the square root of 10. So that means that the absolute value of negative 6 plus 2i is going to be 2 rad 10. And that means that the distance from negative 6 plus 2i to the origin is going to be 2 rad 10. So you remember how to plot these. Here's negative 6 plus 2i. Remember, this is the imaginary axis. This is the real axis. So there's my point, negative 6 plus 2i. And the distance that that point is from the origin is going to be 2 times the square root of 10. All right, let's take a look at the next one, number 33. Now we're into chapter 3. It says rewrite in standard form and classify based on the degree and the number of terms. So if we're going to rewrite this in standard form, we're going to have to write the 2x to the fourth first, because that's the highest power, then 3x to the third, because that's the next power, and then minus 7x, because that's the next power. That's in standard form. The classification, well, there are 3 terms, so that makes it a trinomial, but it is degree 4, so since it's degree 4, we would call it a quartic trinomial. Actually, it probably makes more sense to put those words in this order. So, quartic trinomial. Let's take a look at number 34. Perform the indicated operation. Write your answer in standard form. Okay, so when we work on this, we are going to have to subtract here. Again, I would recommend that you change the subtraction to addition and then change all of these signs here. So I really am going to end up with x squared minus 3x plus 4 plus a negative 3x plus a negative x cubed plus a positive 4. So that's going to give me negative x cubed, because there's no other x cubes that I can combine, then plus x squared, because there's no other x squared, then minus 3x plus another minus 3x is going to be a minus 6x, and then I have the 4 plus the 4 gives me 8. So our answer here is negative x cubed plus x squared minus 6x plus 8. Let's take a look at number 35. Here it says identify the degree. Now this is a monomial, meaning just one term. So to get the degree of a monomial, you actually have to add up the degrees of each individual factor that make up that monomial. So that means that the degree here is going to be 5 plus 6 plus 3, so the degree is equal to 14. Over here, this is not a monomial, this is a trinomial, and so the degree of the whole trinomial is going to be the highest power of any individual term. And since that's 6, the degree here is equal to 6. All right, let's take a look at number 36. We're in section 3.2. It says find the product of the polynomials. If I'm multiplying a binomial times a trinomial, I would recommend using the box method. And for the box method, I need a 2 by 3 box because I've got a binomial times a trinomial. I'm going to make the 2x and the 1 as my headings on my rows, and I'm going to make the 3x squared and the minus 4x and the minus 5 as headings on the columns. And so now I'm going to multiply here, and I get 2x times 3x squared is 6x cubed. 2x times negative 4x is a minus 8x. 2x times negative 5 is a negative 10x. And then I'm multiplying all of those by 1, so I get 3x squared minus 4x and a minus 5. So looking for like terms that we can combine, I can see that we have a problem. You all saw it, I'm sure. This is supposed to be a negative 8x squared, okay? So that clears that up. Okay, so then these need to be combined. Those are like terms. And I'm going to start with my 6x cubed, all right? And then I'm going to have a minus 5x squared. Then I can combine these x terms, and I get a minus 14x, and then a minus 5. So that would be the product of those polynomials. All right, let's take a look at this next problem. This one says expand using Pascal's triangle. Well, Pascal's triangle looks like this. It starts with a 1, then the next row is 1, 1, then the next row is 1, 2, 1, and we get each individual row by adding the two numbers above to get the number below. So 1 plus 2 is 2. So right here, 1 plus 3 is 4. 3 plus 3 is 6, and so on. So our next row is going to be 1, 4, 6, 4, 1. This is actually row 0. This is row 1, row 2, row 3, and row 4. So we want these numbers right here to be our headings because we want row 4 because that's what we're raising this binomial to. So at this point, we're going to set up our chart to help us with this. All right, in my chart, I'm going to have, I think, just 3 rows, but I'm going to need how many columns? Well, there's how many numbers? 1, 2, 3, 4, 5 numbers in this row, so I'm going to need 5 columns. All right, and my top row is going to be those numbers from those columns. So 1, 4, 6, 4, 1. All right, and then when I want to fill my next row out, I'm going to take this 2x right here, and I'm going to raise it to this 4th power. So I'm going to have 2x in parentheses to the 4th. Then the next column over is going to be 2x quantity to the 3rd, then 2x to the 2nd, then 2x to the 1st, and then 2x to the 0. If I'm simplifying these, then 2x to the 4th is going to be 2 to the 4th times x to the 4th. That's 16x to the 4th. 2x quantity cubed is going to be 8x cubed. This one's going to be 4x squared. This is going to be 2x, and anything to the 0 power is 1. So that's what we have here. Then our next row is going to be this negative 3. The sign has to go with it. But instead of starting at 4 and going down to 0, we have to go the other way. So it's going to be negative 3 to the 0, then negative 3 to the 1st, then negative 3 to the 2nd, then negative 3 to the 3rd, then negative 3 to the 4th. At this point, we can simplify those to see what we get. Negative 3 to the 0 is going to be 1, because anything to the 0 power is 1. The next one's negative 3 to the 1st, that's negative 3. This next one's negative 3 times negative 3, which is a positive 9. Negative 3 times negative 3 times negative 3 is a negative 27. And negative 3 quantity to the 4th is going to be a positive 81. Notice that these did go positive, negative, positive, negative, positive, right? Okay, so now the next step is to multiply down. So we're going to multiply 1 times the 16x to the 4th times 1. And when we do that, we get 16x to the 4th. Then we're going to take and multiply 4 times 8x cubed times a negative 3. And we're going to end up getting a negative 96x cubed. Then we're going to multiply the 6 times the 4x squared times the 9, and that's going to give us 216x squared. And then we multiply the 4 times the 2x times the negative 27, and that's another 216, but it's a minus 216x. And then lastly, we're going to multiply 1 times 1 times 81, and we get plus 81. So this is our answer for this problem of raising this, or expanding this binomial to the 4th power. All right, let's take a look at number 38. It says, perform the indicated operation, write your answer in standard form. Since we're dividing by a 2x minus 1, we cannot use synthetic division. We're going to have to use long division. So we're going to put 2x minus 1 out here. That's our divisor. And we're dividing by 6x cubed minus 13, well, we're dividing 2x minus 1 into 6x cubed minus 13x squared plus 19x minus 3. I don't have any missing terms, so I don't have to fill in a 0 for any of those. I'm going to look at this first term here and this first term here and say, what do I need to multiply 2x by to get 6x cubed? And so for this, I'd say 3x squared. But now I need to take that 3x squared and multiply it by the 2x and by the negative 1. So 3x squared times 2x is 6x cubed. And then 3x squared times a negative 1 is a negative 3x squared. And now I need to subtract. So I'm going to put a big parentheses around this and a minus, and I'm going to subtract. Notice, though, that I would rather add than subtract, so I'm going to change that to addition, but then I need to change these signs here. So when I add 6x cubed and a negative 6x cubed, that's 0, and negative 13x squared plus a 3x squared is a negative 10x squared. And I'm going to bring down my next term, which is 19x. Now I'm going to look at this 2x, and I'm going to look at the negative 10x squared, and I'm going to say, what do I need to multiply negative 2x by to get negative 10x squared? Well, I think that's going to be a minus 5x, so I'm going to write a minus 5x right there. Now I need to multiply that minus 5x by both of these terms here. So minus 5x times 2x is a minus 10x squared, and the minus 5x times the negative 1 is going to be a positive 5x. So I'm going to put a big parentheses around this. I'm subtracting, but I want to change that to addition and change the signs here. Now I'm adding. Negative 10x squared plus a positive 10x squared is 0x squared. 19x plus a negative 5x is 14x. And I'm going to bring down my next term, which is the minus 3. And the process needs to repeat one more time. So I'm going to look at the 2x here, and I'm going to look at the 14x here, and I'm going to say to myself, 2x times what gives me 14x, and that would be 7, so I'm going to put a plus 7 right here, but now I need to multiply that 7, no, not you, I need to multiply the 7 by both of these. So when I take 7 times 2x, I get 14x, and when I multiply the 7 times the negative 1, I get a minus 7, and so I'm going to put a big parentheses around this and subtract, and I'm running out of room here, but when I do change this to addition, change that to a negative, change that to a positive, it looks like my remainder turns out to be, can't squeeze it in there, but the remainder is 4. So my final answer for this division problem would be 3x squared minus 5x plus 7, that's our quotient, plus our remainder of 4 over our divisor. And so this is going to be our answer for problem number 38. Let's take a look at number 39, dividing using synthetic division. Well, synthetic division you can use anytime you're dividing by x plus a number or x minus a number. We could not have used that over here because we were dividing by 2x minus a number. Here I would set this x minus 2 equal to 0 to find out what number we're going to put in a little box. So if I add 2 to both sides, I get x equals 2. I'm going to put 2 in a little box like this, and then I'm going to put the coefficients only. No need to write the x's. So I'm going to start with a 1 because that's my x cubed term. I don't have an x squared term, so I do need to fill in a 0. For my x term, I have a 2 as the coefficient, and that's my x to the first. And for my x to the 0 term, I just have a negative 1. So those are my coefficients from x cubed plus 2x minus 1. And then I'm going to do a process of the synthetic division process says bring this 1 straight down and put it below the line. That's my leading coefficient. And then I'm going to multiply the number in the box by the number below the line. And when I do that, I get a positive 2. So I'm going to put 2 right here. And then I have to add the 0 plus the 2, and I get 2. And then I'm going to multiply again the number in the box by the number below the line. This time I get 4. So I'm going to put that right there. I'm going to add these 2, and I get 6. And then I'm going to multiply the number in the box by the number below the line. I get 12. So I have that right there. And then I add these, and I get 11. I'm going to wall off this last number because this last number here is our remainder. And these here are the coefficients of our quotient. Well, this is going to be the x to the 0 coefficient. This is going to be the x to the first coefficient. This is going to be the x to the second, and so on. We always start with x to the 0 just to the left of our wall. So our answer for this problem is going to be 1x squared plus 2x plus 6 plus my remainder of 11 over our divisor, which was x minus 2. And so this is going to be our answer for problem number 39. All right, let's take a look at number 40. Now we're into section 3.4, factor the expression completely. Well, we always should start by looking for common factors. In this case, the common factor I think would be a 3 and an x squared, because 3 goes into 24 and 3, and x squared goes into x to the 5th and x squared. So if I factor that out, 3x squared times what gives me 24x to the 5th? That would be an 8x cubed. And 3x squared times what gives me a negative 3x squared? That would be a minus 1. Now that is factored, but it's not factored completely because we can factor this part further. How do I know that? I can recognize that 8 is a perfect cube, and I can recognize that 1 is a perfect cube. So let's just review what our perfect cubes are. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, and so on. Okay, so I see that we have an 8, and I see that we have a 1. So these are both perfect cubes. 8x cubed, what would I need to cube in order to get 8x cubed? Well, I'd have to cube 2x. 2x times 2x times 2x. What would I need to cube in order to get 1? Well, I just have to cube 1. That means that we're going to use a formula where the 2x is going to be our a, and the 1 is going to be our b. What formula am I talking about? I'm talking about how to factor a cubed minus b cubed, and this will be provided for you on the semester exam. A cubed minus b cubed factors into a minus b times a squared plus ab plus b squared. That's the formula that we're going to use. All right, looks like this. All I need to do now is plug in 2x for a, right, and 1 for b. So when I fill that in, I'm going to have 2x minus 1. Here I need 2x, but it has to be squared, plus 2x times 1. That's my a times b. And I'm going to slide this over a little bit. And then plus my b squared is 1 squared. So my final answer here, since 2x times 2x is 4x squared, I'm going to have 2x minus 1 times the quantity 4x squared plus 2x plus 1. And this is now factored completely. Oops, forgot that we also had this 3x squared that we factored out at the beginning. So let me take care of that issue here. So this is plus 1 in parentheses, and I still need this 3x squared out in front. So this is now our final factored form. The 3x squared times 2x minus 1 times 4x squared plus 2x plus 1. All right, let's take a look at number 41. It says factor this expression completely. So for this one, I think that maybe since there are 4 terms, we might try factoring by grouping. So what can I factor out of a 4x cubed plus 3x squared? Well, I could factor out x squared, and then what's going to be left would be 4x plus 3. What can I factor out of a minus 16x minus 12? I can factor out a minus 4, and I'd be left with, again, 4x minus 3, because negative 4 times 4x is negative 16x. Negative 4 times negative 3 is not right. Negative 4 times positive 3 would give me a negative 12. That looks better. Since I have the same thing now in parentheses, I get a 4x plus 3, and then what's left over here goes together, x squared minus 4. So this is factored, but I don't think it's factored completely because this x squared minus 4 can be factored further. This is a difference of 2 perfect squares, and we have a formula for that. That formula says a squared minus b squared factors into a plus b times a minus b. And so that means, in this case, if that's the formula that we're using, that this can factor into x plus 2 times x minus 2, and don't forget we still had the 4x plus 3. So this would be factored completely. If you were to multiply these all out, you get right back to this. All right, let's take a look at number 42. The volume of a triangular prism can be found by multiplying the area of the base times the height. If the volume of the prism is v of x equaling x cubed minus 8x squared plus 19x minus 12, and the height is x minus 3, find the area of the base. So here's our prism, and the volume of this prism can be found by multiplying the area of the base. So here's our base right here, right? This is the base, and we want to multiply that by the height, which would be here, okay? So, but we already know the volume, and we know the height. Volume equals area of the base times the height. So if I fill in x cubed minus 8x squared plus 19x minus 12, and that's going to be equal to the area of the base times the area of the height, which is x minus 3. So I want to divide both sides by x minus 3 to get the base. So my base is going to be this expression. Now let's just divide this using synthetic division to see what we'll get. So I'm going to take and set this x minus 3 equal to 0. I get a positive 3, so that's the number I'm going to set in the box. And I'm going to put my coefficients, which are 1, negative 8, 19, and negative 12. 1 is my coefficient on x cubed. X squared is a negative 8. My coefficient on x to the first is 19. My coefficient on x to the 0 is a minus 12. I draw a line here. I bring the first number down below the line. And again, I multiply, add, multiply, add. So I'm going to do 3 times 1 is 3. Adding, I get a negative 5. When I multiply 3 times a negative 5, I get a negative 15. When I add these, I get a 4. When I multiply 3 times 4, I get 12. And when I add, I get 0. I put a little wall in to wall that off because that's our remainder, which means since the remainder is 0, this x minus 3 divides in exactly into the volume for the pyramid. So this is x to the 0, this is x to the first, this is x to the second. So our answer here would be x squared minus 5x plus 4. That is the area of the base. All right, let's take a look at number 43. We're in section 3.5. It says find the roots of the equation x cubed plus 6x squared plus 9x equals negative 2. Well, to find the roots of the equation, let's add 2 to both sides. If we add 2 to both sides, we get x cubed plus 6x squared plus 9x plus 2 equals 0. I don't think this one's going to factor by grouping, so if we're going to try and find the roots, I think we're going to reach for our calculator, and we're going to type this in on a calculator and see what we get. So on a graphs page, clear this ink off here, going to a graphs page, and I'm typing in this equation, which is x cubed, x raised to the third, right click to get out of that exponent, plus 6x squared plus 9x plus 2. When I graph this, I see it crossing through the x-axis 3 different times, but I think only this one right here, this 0, seems to be an integer. So I'm guessing that negative 2 might work as a root of this equation. So let's try negative 2. Let's put negative 2 in the box and do synthetic division. We want 1, 6, 9, 2. I don't have any missing terms, so I don't need any zeros. I'm going to bring down the 1, multiply, I get negative 2. Add, I get 4. Multiply, I get negative 8. Add, I get 1. Multiply, I get negative 2. Add, I get 0. 0 is good for the remainder. It means it divides in evenly. And that means since negative 2 worked in the box, that x plus 2 must be a factor. But the other factor would be gotten from these. X to the 0 term, x to the first term, x to the second. So I should also have x squared plus 4x plus 1. Now, does that factor? X squared plus 4x plus 1, the product would be 1, the sum would be 4. I don't think that's going to work. So that means that we are going to need to do a quadratic formula on this. So if I'm going to do quadratic formula, I want negative b plus or minus square root of b squared minus 4ac all over 2a. And so if I'm going to do that, I'm going to have, let's see, opposite of b is going to be negative 4 plus or minus square root of b squared is 4 squared minus 4 times a times c all over 2a, so that's all over 2 times 1. And when I work that out, I end up getting negative 4 plus or minus square root of 16 minus 4 all over 2, which is going to be negative 4 over 2 plus or minus square root of 12 over 2. This reduces to negative 2, and then I can simplify square root of 12. Square root of 12 is equal to square root of 4 times square root of 3, so that's 2 square root of 3. So I get 2 square root of 3 over 2. These 2's divide out, so I'm left with negative 2 plus or minus square root of 3 as my answer for number 43. Actually, not quite. So we're taking a lot of room on this problem, but the roots, remember we had x plus 2 times this x squared plus 4x plus 1. When I set this equal to 0, I get negative 2, so that's one of my roots. And when I set this equal to 0 and solve, I get these two roots, negative 2 plus square root of 3 and negative 2 minus square root of 3. So these are our three roots. Hopefully you can tell that's a negative 2 and a comma. All right, so that's the answer for 43. Now let's back up and do number 44. Let me copy this onto another page if I can. All right, and that's copying really, really poorly. Try this one more time. Still looks kind of messed up, but we'll go with this. So I'm finding the roots of this equation. I'm going to add 2 to both sides, and I'm going to have x cubed plus 6x squared plus 9x plus 2 equals 0. If I want to find, that's not the one I wanted to copy. I copied the right one here. That's the one I want to do. Find the possible rational roots, or possible rational zeros. To get the possible rational zeros, we want to do the p over q values. The p values are going to be all of the factors of this constant term. So that would be plus or minus 1, plus or minus 2, plus or minus 7, plus or minus 14. Those are all of the integers that will divide into 14. The q values are going to be all of the factors of your leading coefficient. So that's going to be plus or minus 1, plus or minus 2. So our p over q values, which represent the possible rational zeros, are going to be every combination of numerator over denominator. So I need 1 over 1, I need 2 over 1, and so on. So let's take 1 over 1, that's going to be 1. 1 over 2 is going to be 1/2. 2 over 1 is going to be 2. 2 over 2 would be 1, but I already have that listed. 7 over 1 is 7. 7 over 2, I need to list that. 14 over 1 and 14 over 2, but 14 over 2 is 7, and I already have that listed. So this is going to be the list of all of the possible rational zeros. All right, let's take a look at number 45. Number 45. Identify the roots of each equation and state the multiplicity of each root. Again, let me see if I can clean this up a little bit. Erase. Okay, so we're looking at number 45. It says identify the roots of each equation and state the multiplicity of each root. Well, let's start off by factoring anything we can. I think we could factor out x squared, and that would leave us with an x to the third minus 3x squared plus 4. All right. And then really, I think we would have to try and graph this right here to see if it crosses through the x-axis at all. So let's do that. We're going to factor x cubed minus 3x squared plus 4 on our graphing calculators. I'm going to a graphs page, adding a graphs page. Let's see, so I want x cubed, so that's x raised to the third. Right click to get out of there, and then minus 3x squared, and then plus 4. And let me get rid of that ink there. Okay, so it looks to me like it's crossing maybe at -1 and maybe at +2. So let's try the -1, for example. If I try -1 in the box, not with the originals, but just with these, the 1x cubed, the minus 3x squared, so x cubed, x squared. My x, the first term, I don't have one, so I'm going to have to fill in a 0. That's like saying plus 0x. And then my x to the 0 term, coefficient is 4. When I do the synthetic division here, I'm going to bring down this first term, multiply, I get -1, add, I get a -4, multiply, I get a +4, add, I get a +4, multiply, I get a -4, add, I get 0. So it does divide in, and I'm left with x to the 0, x to the first, x to the second. I'm left with x squared minus 4x plus 4. But remember, I also had this -1 that worked in the box. So that corresponds to what factor? Well, that would be x plus 1. And don't forget, I also had already factored out x squared, which I could think of as x times x. So if I was to multiply all of this out, I would get back to my original right here. Well, at this point, I want to set each of these equal to 0 to get my roots. So if I set each of these equal to 0, I get 0 showing up twice, -1 showing up once, but I think this factors further. So if we try and factor this, I think it factors into x minus 2 times x minus 2. Again, you could do product sum to work that out, but we want to set these equal to 0. So it looks like 2 shows up twice. So 0 shows up twice, -1 shows up once, and 2 shows up twice. That's if we set these equal to 0. Our zeros would be 0, 0, -1, 2, and 2. And we've written down what our roots are and what the multiplicities are. All right, let's take a look at number 46. This is section 3.6. It says find all the zeros of the polynomial function by factoring. So if we want to factor x to the fourth minus 5x squared minus 36, we can notice that this is an even power. This one is half of that even power, and this is a constant. So it may be possible to factor this using product sum. The product would be 1 times a -36, so that's -36, and the sum is -5. So the two numbers that would work here would be, I think, a -9 and a +4. If I do -9 times 4, I get -36. -9 plus 4 is a -5. So I'm going to take out this minus 5x squared, and I'm going to replace it with a -9x squared and a 4x squared, so that when I put them back in, they will add up to -5x squared. So I'm going to write x to the fourth minus 9x squared plus 4x squared minus 36. I'm going to factor by grouping, so this is going to be x squared times x squared minus 9. This one's going to be a factor out of 4, so I'll have x squared minus 9 again. Since this is showing up in both places, I can factor that out as x squared minus 9, and then I'll have x squared plus 4 left. But we can actually factor this further because that's a difference of two perfect squares. That factors in x plus 3 times x minus 3, and of course we still have the x plus 4. All right, so we've got all of the factors, so now we just need to set them each equal to 0 to find the zeros of the polynomial. So we end up getting -3, +3, and a -4. That's not right. My bad. This should still have been x squared plus 4, not x plus 4. So I take back that last statement. So let's try this. We're going to do x squared plus 4 set equal to 0 and solve. I'm going to subtract 4 from both sides, and I'll get x squared equals negative 4. Take the square root of both sides. I need plus or minus, and I get x equaling plus or minus square root of 4 times square root of negative 1. So that's going to be plus or minus 2i. So our other two solutions are going to be 2i and negative 2i. So those are our zeros for the polynomial. Let's take a look at number 47. It says two zeros of a function are negative 3 and negative 4i. Write this polynomial in simplest form. So let's try this one, negative 3 and negative 4i. I'm going to do this off on another page here. Negative 3 and negative 4i. So these are zeros of the polynomial. So what would be the factors? Well, if negative 3 is a 0, then x plus 3 is going to be a factor. Zeros, factors. And if negative 4i is a 0, then x plus 4i is going to be a factor. But imaginary zeros come in pairs. So if negative 4i is a 0, then positive 4i is also going to have to be a 0. So x minus 4i is going to be another factor. So in this case, I would want to multiply all of these out to get my answer in simplest form. So I'm going to multiply these two together first using FOIL. So doing that, I lost my page. There we go. So doing that, did it again. Let's try it again. We'll find it. Okay. So if I am going to multiply these together, I'm going to do FOIL. So this is x squared. This is a minus 4ix. This is a plus 4ix. And this is a minus 16i squared. These subtract off because a negative 4ix and a positive 4ix add up to 0. This I squared here is equal to negative 1. Remember, I squared equals negative 1. So I get x squared minus 16 times a negative 1. That's x squared plus 16. But I still have to multiply that by the x plus 3. So I'm going to do FOIL again here. So my first terms are going to be x cubed. Outer terms would be a 16x, inner terms would be a 3x squared, and last terms would be a positive 48. So I would write this in standard form. I'd put the terms all in decreasing order by power, and my answer would look like this. X cubed plus 3x squared plus 16x plus 48. Okay, so that was number 47. Let's see if we can go back and find 48. All right, that's here. It says solve the equation by following all of the steps. Step A says graph the function on your calculator. Use synthetic division to prove that the x-intercept you think you see on the calculator is truly the root of the equation. So let's type this in on our calculator, adding a graphs page. And I'm typing in x raised to the third, and then I want minus 2x squared minus 2x minus 3. It looks like it's crossing through at positive 3 on the x-axis, so let's do synthetic division with a positive 3, because that looks to be the root right there. So if I put positive 3 in the box and the coefficients of 1, negative 2, and negative 3, I'm going to try and squeeze this in here, bringing the 1 below the line. Multiply, I get 3. Add, I get 1. Multiply, I get 3. Add, I get 1. Multiply, I get 3. Add, I get 0. So 0 is the remainder. That means that 3 really is an x-intercept, and that means that I can write the equation as a product of two factors. Well, if 3 works in the box, then the factor is going to have to be x minus 3. And the other factor here we get from these coefficients. Remember that this is x to the 0, x to the first, x to the second. So this factor here should be x squared plus x plus 1. Then it says factor or use quadratic formula to find the remaining two zeros. Well, we're going to have to do a quadratic formula, I think, on this, because if the product is 1 and the sum is also 1, I don't think there are any numbers that are going to work. So let's do the quadratic formula. Negative b plus or minus b squared minus 4ac all over 2a. Nice and easy to plug in because the a, the b, and the c are all equal to 1. So I get negative 1 plus or minus square root of 1 squared minus 4 times 1 times 1 all over 2 times 1. I'm getting negative 1 plus or minus square root of 1 minus 4, and that's over 2. So I'm going to put each one of these over 2, and then I'm going to get negative 1/2 plus or minus. This is going to be a square root of a negative 3 over 2, which means I'm going to have negative 1/2 plus or minus I rad 3 over 2. And those would be 2 of the 3 roots, and of course setting this equal to 0, we get 3. So 3 is one root. Negative 1/2 plus I rad 3 over 2 would be another root, and then negative 1/2 minus I rad 3 over 2 would be my third root. So these would be the 3 roots for this equation. All right, let's take a look at number, we can find it, number 49. This is section 3.7. Given that a function has an even degree and a negative leading coefficient, complete the following statements. As x approaches negative infinity, f of x approaches what? Well, as x approaches negative infinity means how does the graph start? Does it start high or does it start low? Well, if it's an even degree, it starts and ends in the same place. All right, that's what we know about even degree. Starts and ends the same way. So if it starts high, it's going to end high. If it starts low, it's going to end low. What do we know if it's got a negative leading coefficient? Well, that guarantees that it's going to end low. So it ends low. All right, so let's fill this part out first. As x approaches positive infinity means how does it end? Well, we just said it ends low. That means f of x is going to be approaching negative infinity. But we know that they start and end the same way. That means it must start not at positive infinity. It must start low also. So is f of x is going to be approaching negative infinity. So the general shape is going to be starting low and ending low, something like this. Let's take a look at number 50. Find the minimum and maximum values for this function. So let's do this on our calculator. We're going to type this in on a calculator page. I'm going to, I'm sorry, not a calculator page, graphs page. And I am typing in 2x raised to the third. And I want minus 3x squared minus 6x and minus 5. There's my graph. I see a relative maximum right here, and there's a relative minimum down here, but I can't quite see it. I could adjust my viewing window if I'd like. Let's see. Well, let me do that here. Sure. So I can make this, let's say, negative 25. All right, now I'm seeing my relative maximum and my relative minimum. Let's find this maximum point first. I'm going to go Menu, Analyze Graph, Maximum. I need the lower bound, which means I want to get to the left of that, not a whole lot left, just a little bit to the left of that maximum. And then upper bound, I have to get to the right of that maximum. And I click, and I get this point. So the relative maximum is going to be this y coordinate right here, negative 2.91. So I'm going to write that for my maximum, negative 2.91. Let's go back and find that minimum value. That's this value that I'm pointing to right here. So I'm going to go Menu, Analyze Graph. This time I want minimum. So I'm going to go to the left of that minimum and click. I don't want to go way far. This would be too far. I want to go just to the left of the minimum and click, and to the right of the minimum and click. And I'm getting this ordered pair, which means negative 14.1 is the relative minimum for this point. So negative 14.1 is what we fill in right here. All right, and that concludes this video, because the pick up 3.8 on a different video. All right, so good luck studying.